Hello, everyone. Good afternoon. So, in my time, this is afternoon. So, today I would like to share about how to make or how to design a primer. So, in this case, I would like to share about the gene of Oryza sativa itself. So, basically, if you have different gene, maybe from different organism, like maybe in plant or fungi or microbes, you can adjust this and you can follow the general instruction from me. So before that, I would like to share about this slide. So first thing first, I would like to make sure that you have or you must to clear about this instruction. So I'm sorry, it is still in Bahasa, but I will explain in English. So basically, if you want to make a design primer, so you must to prepare three websites. So basically, it's not about three, two is enough. Only the data gene database or gene bank like RAPD or just in Oryza fast case, you can choose like uh what is it ensemble plan I'll show to you after this slide. So the second one is about the primer 3 plus, and in this design primer we will have some option for design the primer, and we can choose which one the best for our primer. So in general requirement, you must to have three general requirement to make a primer. First thing first, you must to have 20 until 22 pass fair. So yeah, the primer only 20 until 22 best pair. A, T, C, G only 20 until 22. And then the second one, the temperature melting between 52 until 58 Celsius degree. So we don't need more than 58 because the annealing it's optimal only in this what is it this uh 52 until 58 degrees Celsius. And then the third is about the GZ content or guanine cytosine content only have um 45 until 60%. Why? Because the GC content have the hydrogen bonding, so it has three like this. So this is the strong relation between C and G. So it must have maximum 60% for make a design primer itself. So this is I only have one slide. This is for general requirement. So the next I would like to share about uh this is my database, which is the gene summary for Orza sativa, of course. I have 10 gene in here in this slide. And for an example and to show how to make a primer design, I will choose only one gene, and I will demonstrate it to you. Next, I would like to show about the, where is it? I'm sorry, it's still in the Zoom page. Okay, this is what I said before. Oh, I'm sorry. Okay, this is what I said before about the ensemble plan. This is uh the specific website for the Oryza sativa gene bank. We call it ensemble graminae. If you have different organism, you can check the specific gene. You can search in your Safari on your Google. So basically, in graminae, this is about the something like maybe Arabidopsis or just what is it, wet or something in cerealia. So we can search the locus ID in here. For example, like this. This is about the rice. For example, I'll copy the slide like this. Okay, we can adjust the T and change for the G like this. Okay, wait a minute, and then okay, you can see here showing one gene font in horizontal file like this, and then we click it. Okay, and then we choose the trans like this. Mm-hmm. Uh, let's we read about this one about the transcript. The transcript has three exon. So basically, if we try to understand the concept of um, what is it, dogma central, or just maybe how to protein synthase, how to make a protein. This is about the transcription, translation, and the modification after transcription is about cut the intron and only exon that uh, can be translated into the protein. So yeah, this is the exon. In this gene, we only have three exon. We don't need intron because that I said before that intron has no function for uh, synthase the protein. So for example, I'll copy this for exon 1, okay, common C for in Mac, and then we're going to website the primer 3 plus like this, and then first thing first, you will um, see the main like this, and then you can change the general setting. Don't change anything except the maximum TM difference. This is before that, if I'm not wrong, this is 100 for the maximum temperature melting difference, but you can change it into the three, only three, because we don't need a big gap, only three. So you can change into the three. And then what's next? I think, okay, only this. And then we're going to the main page, and then we paste the sequence like this. And then we click the pick primer. Okay, wait a minute. Okay, you can see here. Oh, okay. If you want to choose which one the best primer for your primer, you can choose um, the option that don't have a hairpin like this. So you see, if you have seen this hairpin, the line which is 5 line, right? Don't use it. Don't use it. We can choose another option. You can click next primer pair. Oh, this is still have a hairpin. Next, next. Okay, this is still. Oh, okay. So basically, in this case, we have 10, what is it? 10 option, but no one don't have the hairpin. So if the case like this, you can change the second exon like this back to the gene bank or the website. You can choose the second uh, exon and then go back to the main section like this and paste, and you can pick the primer. Okay. Mm-hmm. 2, 3, 4, 5, 6. Okay. So basically, why it's only have 6 options? Because the gene sequence is very short, like this, only 100, 101, right? So the option is very uh, a little option, I mean. Okay, go back to the website and then you can choose again the third exon, the last exon, I mean in this gene, back to the main section and then paste and then pick your primer. Okay, we're going to the first primer to make sure everything is detected by us. Okay, no. Oh, okay. If three three what is it, 3 exon have no chases for that, we can go back to the website and uh don't use all of the sequence in exon 1, for example. You have to choose maybe just a half of the exon 1. It's up to you, maybe like this, and then going back to the main section and then del paste and pick the primer again, going to the first primer next. Okay, this is for the best choices. I think you can see here there is no hairpin or dimers, if we call it. um you can see here the time melting between for the left meaning forward primer and right primer meaning reverse primer, forward and reverse like this. Okay, and then you can see here 59.4 degrees Celsius for the forward, and for the what is it, for the reverse, it has 60.3 degrees Celsius. So about the GC content, it's still in our standard, which is 55 and 60%. And yeah, we just need to see this requirement, general requirement. So we can choose this forward and reverse primer. And okay, we can copy paste this. For example, I will show you about, okay, in this slide again, guys. I'm sorry. I will take it in the next column, we just write the forward primers like this, 5 accent, and then reverse primer, which is 3 accent. Okay, something like this, and then we copy paste this primer. Then the right primer, which is the reverse primer like this. So yeah, well done, guys. So this is the best primer. Okay. If you want to write completely information, maybe like about the temperature melting or just what is it, GC content, you can write in here. For example, I will write this temperature melting. This is about the degree Celsius, right? Like this. I'm sorry. Oh, there is an option to make it small. Okay. For this is only for example, guys. So it's okay if you write like this, and then what's it? Oh, okay. GC content once again. GC content. Okay. Percentage like this and like this. Okay, it's clear. Don't forget to save the file, and then the temperature melting, it's about like this, right? And then the temperature melting for the reverse is about like this, and then the GC content, you can see here, 60%, and the GC content for the reverse is about 55%. So yeah, well done. Completely well done. So you can see here about the design primer. And what the next after this, you can order the forward and reverse primer to the some company, genetic company, and then you will get the pellet, and you must to aliquot the pellet, and you must to have the wet laboratory, I mean laboratory, and then you must do doing the PCR amplification to make sure that your primer is completely uh, work and good work. Okay, so that's it. That's all for me. From me. I'm sorry if I have a mistake, and if you still confused about my explanation, my what I say to you, what I mean, you can contact me in the email below in my description. So thank you very much for watching my video, and see you to the next video, and goodbye.